So the first question, and we may have went over this one, I can't remember because it's not dark like the other ones. So I don't know if we went over it or we clicked on it or what. And this is 9.1. When this may be, let's see, I don't think we've covered this. This may be arc length. So I may just wait. And yeah, it is. Okay, so let's wait on this one and get to it when we do the, I will do the presentation today and we'll go over that. Use that as an example. Chapter contents 9.1. And I'm going to go to the last section, which is two formulas. There, that fixed it. Two formulas, arc length and arc area. Now, when you're talking about the arc length, you're talking about the side of the circle between the two radii, okay? Or between the radiuses or two radii. I'm getting there. Hold on. Arc length. There it is. And I'm going to blow this up a little bit. Now, this is something that you might see on a standardized test. Now, I'm going to ask you this question. I'm going to ask you this question also on a regular test, but there's the formula right there. S is equal to radians times theta. I'm sorry, radius times theta, and theta is going to be in radians, so it's going to have a pi in it. Okay? And you're getting that length right there. That's called the perimeter length. Okay? So, an example right here. It says a circle has a radius of 18.2 centimeters. Find the length of an arc. Well, 3 pi over, that's already in radians. So what you would do there is you would take R is equal to 18.2, and you're going to multiply that by the radians, which is theta. Theta is usually in radians or degrees. 3 pi over 8. So arc length is equal to R times theta, which is going to be equal to 18.2 times 3 pi over 8. Now, sometimes they're going to want it in terms of pi. Sometimes they're going to want it in terms of a decimal. Okay, I'm not going to fret over that because I think y'all can discern when to do it and what to do, you know, with your calculator. So I'm going to say 18. Let's see, is that 48.6? I think that's 48.6, isn't it? No, that's 16. 16 is 48. So that would be 54. I think 54.6, but somebody check me. 54.6 pi over 8. Now that's in terms of pi. And of course, if you wanted to turn that into a decimal, you could turn that into a decimal. Sorry, hold on. So somebody turn that into a decimal for me. Well, I'll just pull it up. Y'all don't like to communicate with me, so I'll just pull it up on the handy dandy TI-84. Y'all give me complexes, I won't be able to teach next semester. 54.6. I must have pissed y'all off. Y'all talked to me last time. Pi. And hell, I can't even see pi. You got a blue background, and is it right there? Divided by 8. So the arc length of that portion is equal to 21.44 centimeters. So basically what they're saying is, if you have a circle, and that circle has a radius of 18.2 centimeters. Now, it's very important that you see this, because when you're talking about a gear or a pulley, this comes into play. All right, 18.2 centimeters, and that turns, let's see how much it turns. Let's turn this into 180 over pi. Pi's cancel. That leaves you with 8 into 180. 8 will go in there, what, twice? It won't go in there. I'm trying to think of 4. 4 will go into 8. Yeah, I think 4 will work. Yeah, 4 would be 45. So 4 will go in there 2 times. 4 will go in there 45 times. And that's going to leave 3 times 45. 3 times 45 divided by 2. 3 times 45 is 15. 135. Somebody check my math over 2. And that's going to be 62.5 degrees. Let me check that right quick to make sure. I would ask y'all to help me out, but like I say, y'all don't want to interact with me. So I'm just going to take 180 divided by 45. Yeah, that's right. 135 divided by 2. That should be right. But 3 times 45 is 135, and divide that by 2. 67.5. Sorry. I always do that.
Is that to change your radius in terms of pi? What you just did, I mean.
No, the reason I'm doing this is because I want to see, nobody thinks in terms of pi. When you're talking about an angle, I want to know where, I want to show y'all what I've just found. So I'm doing this for me, okay? You do this in the question. I'm doing this for me. 67 degrees. 67 degrees would be, well, that's 45 degrees. 67 degrees would be about right there. So that's your 3 pi over 8. So what we just found, and this is important for you to see, we just found this length. And that's equal to 21.44 centimeters. Who asked that question a while ago? Do you see why I did the 67.5? I did that
Yes,
just
sir.
for me, just so I could measure it. You see?
Yes, sir.
Okay. Because nobody, if I told you 5 pi over 2, would you know exactly where that was?
No.
Nobody does, unless they're, you know, as Johnny Depp says, you're really weird. Unless you're really weird, one of the off, 67.5, that's 3 pi over 8. You don't think in terms of 3 pi over 8. So I turned it into 67.5 so I could see where to draw it to show you what that length looks like. And that's about right, because this is close to 18 centimeters. And if this is close to 18 centimeters, why is my hand frozen? If that's close to 18 centimeters, then yeah, this is going to be around 21. So it's going to be a little bit longer because it's a curve. A curve is always longer than a straight line. That's a good question. That's a good test question. Why? Because it's short and sweet. Okay. Now, the other one said a radius of 18.2 and theta is equal to 144 degrees. Well, you got to change that. You got to change it to radians. So that's over 1 multiplied by 180. I'm sorry. Multiplied by pi over 180 degrees. And I know my degrees cancel. That's why I put 180 on the bottom. We talked about that last class. So now I just got to reduce it. That's 144 pi over 180. And now I just need to reduce. Well, I know 2 will go in there. That's 72 over 90. And that's 36 over 45. And 9 will go in there, 3 over 5. So that's 3 pi over 5. Y'all check my math. I think that's right. 9 times 3 is, no, that's not right. 4 pi. Is it 4 pi? It should be 4 pi.
Yeah, it's 4
times
pi over
9
5.
is 36. 9 times 5 is 45. Should be. So now we got, so 144 is equal to 4 pi over 5. Now this one's easy because you know where 144 is. Here's your radius. Radius is equal to 18.2 centimeters. And you're going, here's 90. You're going 144. Well, here's 180. 90 plus 45 is 135. So 135 is right about there. So I'm going to say 144 is about right there. Or if you want to put it in terms of pi, 4 pi over 5. Okay, so you're finding this curve right here. Now you know that the angle to about right here is 21, because you found that one. So I'd say it's going to be probably double. I'd say it's going to be around 42, 45, somewhere in there. It's going to be double, or at least double, close to double. So here we go. Arc length, which is L, is equal to 18.2 multiplied by 4 pi over 5. And nothing cancels, so I'm just going to take my handy-dandy calculator and I'm going to write it in terms of pi. And that's going to be 18.2 times 4 pi, or 4. That's equal to 72.8 pi over 5. That's one way to write the answer. But since we're talking about centimeters, and since we started with a decimal to the 10th power, to the 10th decimal point, I'm going to change this to decimal. So times pi divided by 5. And I hit multiplication. I suck. Divided by 5.
Did you say we would be able
45.74. What?
Did you say we would be able to use calculators for the exam?
Oh, yeah.
Okay.
Yeah, some of y'all are on the calculator drill team, so I can't take that away from you. Y'all convulse if I did that. And plus, I mean, in a day, I mean, just like now, if I went out and bought a theodolite and was going to use it for land surveying, you wouldn't even have to read an angle. I mean, you could just hit input and it'd go directly into the HP. I mean, so, you know, nowadays it's kind of hard to, you know, do things by hand, but you see where I'm going with this. Make sure you can do both ways. And yes, you will use calculator.
I have another quick question.
Yes, sir.
Why did, at the beginning for theta, why did you have to change it into radians instead of just leaving it into degrees?
Well, the arc length has to be in radians. Okay, I mean if you go back to the actual, hold on a second. Hold on, right here. It has to be in radians. Where's the formula? There it is. Theta is in radians. See there? Now,
Yes,
if you want to take your calculator and convert it and then do it, that's fine. And some calculators will take theta as long as you tell it, as long as you tell it whether you're in degrees or radians, it'll do it for you. Okay? So what kind of calculator do you have, Mr. Michelle?
TI 84 plus CE.
So it will probably do it for you. Did you put in 144 or did you change it to 4 pi over 5?
I just changed it to 4 pi
Yeah,
over
you don't
5,
want
like
to
you
put
did.
144 if you don't know how to do it. If you put in 144, it's not going to give you the correct answer.
Okay, thank you.
With me? So make sure you make that note right here. If you're doing this by hand, and that's what we're doing, even though you're using the calculator, we're still doing it by hand. You want to make sure that theta is in pi mode, which means radians. Okay? All right, so let's move over to arc length, which is the next formula, which works about the same way. Arc length is area is the 1/2 r squared theta. So write that down. Now you're finding this area of the pi right here. So if we take this same, let's take this same problem that we're doing. I'm not going to do theirs. I'm going to do the same problem. Write that down. I'm going to write it in pink. Area equals 1/2 r squared theta. And remember, theta has to be in terms of pi. Okay, hopefully y'all got that written down. I mean, it's just that. And that's a cursive A. I don't really care about that. You can write A of A sub S. You could write, I don't care what you write, but that's the formula, 1/2 r squared theta. Okay, I'm going to pull this back up. All right, we're going to find this area right here. Now, a lot of you think, well, Hubert, why do we want to find the area of a circle? Well, that's not where you use this. In programming, when you program it, you can find this is a horizontal curve on a road. Okay, let me show you where this can be applicable, especially if you're a civil engineer, construction management, something like that. You have a dang old road, a proposed road that's going through here with a horizontal curve like that, and you've got a man's property line that goes here and a man's property line that goes there. Okay, and you want to buy up this right of way right here, and what's left is the acreage that man owns. Now, we're not talking about 5 acres here. We're probably talking about 200 or 300 acres. This man owns, I'm just using this, he owns this block of land right here, and the new road, it's not, they got a big lake right here, and they can't go through the lake, so they're going around it. And they want to find the acreage using this curve right here. Okay, now that is derived, you use calculus also, but it comes from this, what we're learning right here. Okay, so I don't want you to think I want you to think out of the box. I want you to think out of this circle, because nobody is going to walk up to you and ask you to do this in real world. But they will ask you to do something like this. And that is derived from this and added with some calculus, area under the curve, you get that. So it all plays into what you're doing. Okay, so we're finding the area in this circle, in that segment. So area is equal to 1/2. R is 18.2 squared times 3 pi over 8. And what do you notice about these two formulas? They're pretty what? They're pretty simple. Okay? You just got to know where to plug and how to plug and chug. So area is equal to 18.2 squared times 3 pi over 16. And now that's a calculator question. So I'm going to take my handy dandy calculator. And I'm going to take, now you can leave it in terms of pi by taking 18.2 raised to the second power times 3. At 3 and at 6, that'll cancel. No, 3 goes into 18, not 16. I get that confused all the time. All right, so times 3. 993.72 pi over 16. And you can write it like that. But since they're wanting a distance here, they're going to want square feet or square meters or square centimeters or whatever as far as your area. So I got that through times pi divided by 16. So in that pink area, you've got 195. Area is equal to 195. We started with a tenth, so we're going to go to a tenth. 0.1 square what? Centimeters.
Can you explain how you did the second step of that equation?
The second step right here?
No, below that.
Right here?
How you got, yes, sir, how you got to that?
I did 18.2. 18.2. Caret symbol. Second power. Times 3. Times second. I can't see it. Caret symbol. And that's my numerator. And just divide it by 16. Did you get it to 195.1? Did you get it come out that way?
Oh, I'm just trying to see how you got the area equals 18.2 squared times 3 pi over 16. I'm wondering how you got to that step.
Well, here's the 18.2. So that goes right there. And then the theta is 3 pi over 8. Goes right there. And then 2 times 8 is what? 16. And then what's left is 18.2 squared over 3 times 3 pi.
Did you not have to distribute the 1/2 to the 18.2 squared?
Can't do that. Well, I did. I mean, 2 times 8. That's. I mean, you can move this around all the way you want to. You can take that 18.2 squared, multiply it by the 3, and divide by the 16. You can take that 1/2 and you can multiply 18.2 and divide it by 2, and then multiply that by 3 pi. All this is multiplication, so it doesn't matter how you do it.
Okay.
Okay, so you could take, let me just do that for you. Let me take 18.2 squared. So I'm going to take 18.2, well, 18.2 squared, divide that by 2, or multiply by 1/2, and then multiply that by 3 pi. Multiply by 3 second pi equals, and divide that by 16. Okay, you should get the same thing. You should get the same thing. I don't know why you don't. Let's try it again. 18.2 squared divided by 2 multiplied by 3 times pi and divide by 16. Oh, no, you don't divide by 16. Divide by 8. There we go. There we go. There you go. You get the same answer. Whew! I'm beginning to think I'm crazy. Yeah, thank you, Mr. Parrish. Yeah, divide by 8 because I didn't multiply that 2 by. You understand? Since
Yes,
I
right, now I
multiplied,
see it.
okay, it works. It works both ways. Okay, now let's do this one. Let's do that one. Let's find the area of this area right here. I'll put it in pink. We're going to find the area. Now, we already figured theta is 4 pi over 5. So you don't have to recalculate it. You just have to plug and chug. So I'm going to take my pink pen and I'm going to multiply. I'm going to do it up here where I got a little bit of room. Area is equal to 1/2 r squared theta. So that's going to be 1/2 times r is 18.2 squared times 4 pi over 5. Now again, however you want to do it, you're welcome to do it. Just don't mess up the division, okay? In other words, if you want to multiply 18.2 times itself and then multiply by 4 pi and divide by 10, you can do that. If you want to take 18.2, square it, divide by 2, and multiply that by 4 pi over 5, you can do that. It doesn't matter. You should get the same answer. So I'm going to just do it all the way across. I'm going to take 18.2 and I'm going to square it. And I'm going to multiply it by 4 pi. And that's going to give me a big number on top. And I'm going to divide that by 10. Of course, you just move the decimal, but we're going to divide by 10. And that's going to be 416 square centimeters. 416.2. Well, technically 0.3. So 416.3 squared centimeters. And that would be about right because this one was close to 200 square centimeters. And we've already established that this is about twice the area or the length. It was twice the length. So standard, it'd be twice the area. And 2 times 200 is 400. And we got 416. So it's pretty much double the size of the first one. And that's how you use those two formulas. Now, where do students get them wrong? I'll show you. It's when they need to use a little bit of critical thinking. And that's where you're talking about gears and other stuff. Let me see if they got one. I doubt they have one. Let's see. Let me go back. No, that's not the one I'm looking for. We'll probably have a homework question here in just a minute. Make sure that that covers those two sections. Okay, here's one right here. A belt runs a pulley of radius 6 centimeters at 80 revolutions per minute, as shown in the figure right here. Okay, find the angular speed of the pulley. Well, up here, angular speed, let me go back because they've got that. I thought we'd covered everything, sorry. Let me cover angular speed, which is another formula. Should be this one right here. Okay, W is equal to theta over T. Okay, theta over T. And velocity is equal to R times W. There they are right there. Now let's go back over to it because we got that right there. And you can see how they're doing it right here, but I want to get to that problem because that's all right. Find the angular speed W of the pulley in radians per second. Find the linear speed. Well, the angular speed is how much a point moves on the edge at a certain angle. Linear speed is how fast is this actual pulley turning. All right. In 1 minute, the pulley makes 80 revolutions. Okay. A belt runs a pulley of radius 6 centimeters at 80 revolutions per minute. And of course, they say that right here. In 1 minute, the pulley makes 80 revolutions. Each revolution is 2 pi. And you know that because 360 is equal to 2 pi. Okay. So with 80 revolutions per minute times 2 pi, that's 160 pi radians per minute. Now you got to write that down because I mean you don't have to. If you got a book with you, all you got to do is highlight this. Okay. Usually, if they're asking about revolutions, you're going to multiply that number that they give you times 2 pi, and that's just normal. And that's radians per minute. Now, the angular speed is equal to the 160 pi, which we just found, divided by 60. Because there's 60 seconds in a minute. And that angular speed is 8 pi over 3 radians per second. Now, you could change that. 8 pi over 3, 8 pi over 3 multiplied by 180 over pi is equal to, the pi's cancel, 3 go in there, 60. 60 times 8 is what? 480? 480 minus 360 is 120 degrees. So that pulley turns 120 degrees in one what? Second. In 1 second, that pulley turns 120 degrees. That's called the angular velocity. Now, the linear speed or the velocity is going to be equal to your radius times your radian speed, your radian speed or revolutionary speed, radians per second, your angular speed. Okay, so that means I'm going to take that 6, V is equal to 6, and I'm going to multiply by 8 pi over 3. And that's going to give me, let's see, that 3 will cancel there. 2 times 8 is 16 pi. V is equal to 16 pi, which is equal to 16 times, let's do that on a calculator. That's going to be 16 pi equals 50.26, 50.26 or 27, and I don't know what the units are. Let's see what the units are. I don't know if it was centimeters or meters or what. Centimeters per second. 50 centimeters per second. So you got to write down these I forgot about angular. These go ahead and write down those also. So you got 4 formulas that you might want to be aware of. There you go. You've got the arc length, the arc area, the angular speed, and then the velocity, which is R times W. Okay, so let's go back to the homework question. And this is the question, and it says, there's the question. All right, first of all, I don't want you to look at this. I don't want you to look at what they're asking. I want you to write the question. I want you to draw that picture. The first thing you do is draw the picture. So I'll be drawing the picture like you, and then we'll address what they're looking for when I get through drawing the picture. 9.15 inches. We got something pulling a weight, pulling down on it. It says, how many inches will the weight in the figure rise if the pulley is rotated at 71 degrees, 40 minutes? A is equal to 71 degrees, 40 minutes. And 71 degrees is less than 90, so it's going to be something like that right there. So there's my drawing. Well, we're going to have to change that 7140 into what? Radians. So let's change it into radians. Now, if you got a graphing calculator, it'll do it for you. But if you don't, you got to change that into a decimal. So what do we do to change? We know the 71 doesn't change. 71 degrees. So that'd be 71 point something. How do we get decimal out of 40 minutes? 40 divided by what?
60.
Somebody do that for me. Oh, I'll do it. 40 divided by 60. I got 0.67 degrees. So now we got to change that. So 71.67 degrees over 1 multiplied by pi over 180. And of course the degrees cancel. And since the degrees cancel, you're left with 71.67 pi over 180. Now, of course, you need to change that into a decimal if you want to. That's up to you. And then I'm going to multiply that by R, which is 9.15. So I'm going to add to 71. And I'm going to multiply that by pi. And divide by 180. And multiply by 9.15. I got 11.44 inches. Take my handy dandy around to the nearest tenth, 11.4. And we feel good about ourselves. Okay, now, what does it say? Through what angle? So you're trying to find theta now. So I'm going to go over here and I'm going to do this in another color. Let's do it in orange. Now it says what angle? It says through what angle to the nearest minute must the pulley be rotated to raise the weight 5 inches? Well, first of all, let's write down our formula. Arc length is equal to R theta. So if I want to find theta, theta is equal to L divided by R. Okay, so in this case, they give you, let's see, through what angle to the, it must be fully rotated to raise the weight 5 inches. Well, the length that you move here is reflective upon this weight length right here. Okay, so those two are going to be equal. So the length is what we're looking for. I mean, length is used, and we know that that's equal to 5. So 5 over R is 9.15. How are they going to do this without the inverse? Okay. And that's going to be your angle. But you got to change it over into, and I'm going to see, I want to make sure that they're not using the inverse. They can't use the inverse yet. Okay, that's, let me see what they're doing here on B. Yeah, that's what they're doing. You get a big number over a big number. I was making sure. They must be going to leave it. Yeah, they're multiplying it by 180 over pi. That's it. That's it. So change that to 180 over pi by saying 5 over 9.15 times 180 over pi. Because technically this is in pi. This whole thing is in pi. And you're basically getting degrees. So that's going to be 5 times 180. So 5 times 180 divided by parentheses 9.15 times pi, close parentheses. 31.30, I'm going to write it out because you need to change it to this. 31.30916,913 degrees. And you change that into degrees, minutes, and seconds. So that means I'm going to take 31, or excuse me, I'm going to take minus 31, and I'm going to multiply by 60, right? That gives me 18. So that's 31 degrees, 18 minutes. And that 55 is going to be right at 1 degree. So it's going to, 1 minute. So it's going to be, so point minus 18 and multiply that by 60. And that comes out to be 33 seconds. So with that being said, let's say 31:18, and just wants you to, technically it's 31:19 because 33 is more than 30. So I'm going to say 31:19. And we feel good about ourselves. Now that is a test question. I like that question because it's short and simple and it's to the point. Now the ones I don't like to put on a test are the ones that you gotta like think out of the box and in the box and all that. Those are good for homework. But I like this question because it's pretty straightforward. Question on that one?
Yes, sir. I have a question.
Oh, yeah. Show you the paper. Yes. Hold on.
For part B, how did you get the 5 for 5 over 9.15?
Right here. I just solved this for theta. This is L, arc length, is equal to R times theta. And I just solved for theta. How do you get rid of dividing by multiplying by R? You divide by R. If you do it on one side, you do it on the other.
Yes, sir. But how did you know that the length was 5?
Because in the original problem, right here, 5 inches.
So it said it rotated at 5 inches?
Yeah. It says how much will the rotated, says to the nearest minute, must the pulley be rotated to raise the weight 5 inches. And that's where I told you, if you raise the weight 5 inches, then that means that this arc length is equal to 5 inches. And that's why I colored them orange. These two are equal.
Okay, I see what you mean.
Think of a bicycle wheel. If you turn a bicycle wheel 15 feet, then that means you've traveled 15 feet linearly, or 15 inches, not 15 feet, but 15 inches.
Can you screen up a little more? I can't see the bottom.
Oh, y'all are just divas. That's what it is. Y'all are divas. There you go. Is that good?
I'm wondering, what'd you multiply 5, or didn't you multiply 5 by something?
5 by 180.
Okay, yeah, I just can't see that, and that's kind of.
Why can't y'all see it?
My mute and the camera thing at the bottom is like.
I don't know how y'all. I think you can click. I got rid of mine. You should be able to move it, or you should click on the dead area, and it should go away.
Oh, there it goes. Okay, thank you.
I don't know what I'm gonna do. Y'all just like attention, don't you? That's what it is. Y'all just like attention. That's a joke. And that's equal to, what did I get? Oh, okay. That's equal to this. And then I changed it from this to that.
You got the 19 minutes because it was 33 seconds, right? And you just rounded up.
Good job. Okay, so let's do a nerd. This is 9 point, well, we're going backwards now. Okay, I thought it put it in order. I'm sorry. Let me hit, I did subject. Supposed to put it in order. Oh, well, that's one of the harder questions. Let's go do this one. 9.131/7. Perform the calculation. Okay, this is a test question. And it's a standardized test. Oh, that last question we went over, that's a standardized test question also. The problem with the weight and the pulley, that's standardized test question. So 47 25 minus 34 55. Now, what's the problem here? Somebody tell me what the problem is. We got a problem, Houston.
You have to convert 1 minute into 60 seconds for 34 degrees, 55 minutes.
Because why?
Because the minutes for 34 degrees is larger than the minutes for 47 degrees.
And you can't take away, you can't get blood out of a turnip, right? You can't get money out of somebody that's broke. So you got to what? You got to borrow. Or if you're from around here, borrow. Okay? So we're going to borrow. We're going to borrow 1 from this, 1 degree from this 47, which would make that a 46. Now, we can't just add 1 degree to a minute. You can't do that. That's like adding an apple to a bushel of oranges and calling them oranges. You can't do that. So what you got to do is you got to convert this 1 degree into 60 seconds, 60 minutes. And when you do that, you change the whole problem to 46 degrees, 85 minutes, minus 34 degrees, and 55 minutes. And now you're ready to lock and load. So go ahead and finish it. So 85 minus 55 is 35. And 40 or 6 minus 4 is 2. And 4 minus 3. So 12 degrees, 35 minutes. Sorry. 12 degrees, 35 minutes.
Wouldn't it be 30 minutes?
Yes, ma'am. I'm sorry. I can't add.
No, you're good.
No, I suck. 30 minutes. There we go. Sorry. There we go. So let's type that in. 12:30. So we type 12 and 30. And we feel good about ourselves. That's a good test question. Next, I'm going to delete these two so I don't get confused. All right, this one is 9135/9. First of all, is it a test question? Yes, it is a test question. At least you're sending good questions, not them Philadelphia lawyer A through Z. I can't stand those. All right, convert the measured angle to decimal degrees. Now, this is the one you don't do because nobody uses decimal degrees, only in academia. 52 degrees and 24 minutes. 54 degrees and 24 minutes. Now, just for your own benefit, I'm going to pull up the book. And I'm going to take you back. Take me back. Do 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 do. Y'all know Rocky? Y'all ever see Rocky movies? Just forget it. It's not a cartoon.
Yeah, the Rocky
Some people
movies
watch.
are awesome.
I love those. Those are my favorite movies, except for Rocky 5. Rocky 5 should have never been made. Sylvester Stallone said that. He got greedy for money, so he decided to write out a. Oh, it was terrible. Okay, where is it? Convert. Because this is where people can get confused. Well, I must have passed it. There we go. Is this it? No. Here we go. Are they supposed to have it? Here we go. There's how you do it. Now, I brought it back because a lot of people get confused about changing degrees, minutes, and seconds because they think you do it this way. Now, this is when you change from decimal to degrees. This is where you change from degrees to decimal. So we've got minutes, so we just divide by 60. So 52 degrees and 24 divided by 60. So I'm going to take my 24 degrees, 24 minutes, and divide by 60. And that's going to be 0.4. So my answer is 52.4 degrees. Now, you do have a way to do this on your calculator. And I'm going to show you. It's under the math key. I think it's under math. Where is the degrees, minutes, seconds? I always can't find them. You can use angle. Where is it? Is it under? Oh, there it is, angle. You use second angle. There it is. So we're going to type it in. Let me hit clear. So 52 second angle, which is apps, degrees, and 24 second apps, minutes, and then hit enter. There you go. Now, what if you had degrees? Well, you got a quotation down here somewhere. Isn't it above the plus sign? So if you needed to change 52 degrees, this is a pain, 24 degrees, and 15 seconds. You hit 15, then alpha, I'm looking for it, alpha plus, and enter. And that's how you use it. Second app. Now you got to practice it. You can't just do it once or twice. You got to practice it. on your calculator, or you can just do it by hand. Now, if I had 52 degrees, 24 minutes, and 13 seconds, then I would do 52.24 over 60 plus 13 over 3600. And that's how I would do that. And you can go back, and that's where they get the 3600 right there. So if you have a book, page 614, example 3, that's what you need to write down if you suck at changing from decimal to degrees and degrees to decimals. Or you can use the handy dandy calculator. All right, so that's a test question. So 52.4 degrees. (9.183/21). And I need to finish up soon because some of y'all are going to start convulsing. Convert the radian measure to degrees. Well, I'm going to multiply. We know this is in radians, so that means that it is in pi mode. So that means I'm going to write 2 over 1 2 over 1 multiplied. I got pi is in this calculation. Pi is in that 2 calculation. So I'm sorry. I'm going to put pi in pink. You don't see pi, but to get that 2, because it said radians, 2 radians, that means pi is in that calculation. Does everybody understand that? Let me see a raise of hands if you understand what I'm talking about. Okay. Okay, good. In other words, when you see this problem right here, convert the radian, you might have a 2 here, which means 2 has a pi calculated in it, or you're going to have a pi beside it, be like 4 pi or 2 pi or whatever. Now, since it says radian, and since this just says 2, that means that I calculated pi to get that 2 right there. So you got to be careful about that. So that would be 2 pi, or 2 over 1, and then I'm going to multiply that by 180 over pi. Now, technically, if you broke this up, the pi's would cancel. But since it's not there, since it's inside the 2, we're just going to cancel it out. I mean, we're just going to use it as 3.14, and we're going to get the answer. So that would be 2 times 180 is 360 divided by pi. So 360 divided by pi. And that's 114.59 degrees. I don't know if it wants it in. We'll see in just a second. 114.591559. I don't know what they wanted in. Let's look and see. Okay, so we need to change it to the nearest minute. So we're going to multiply. Let's see, we're going from, yeah, we got to divide, yeah, divide that by 60, right? No.
I thought you would multiply it.
Multiply it by 60 and then find the remainder, yes. So 0.59, I had to go backwards, minus 114, because we know it's 114 degrees. So 114 degrees, and then multiply that by 60. and that's 35 minutes, and minus 35, because we know that's minutes, and then multiply that by 60, and that is seconds, 30 seconds. Okay, so 114, 35, 30. 114, and they want it to the nearest minute. So that 30 is more, it's 30 or more, so I'm going to say 36. Uh-oh. Let's see. I bet it's a rounding. Let's see what they got. Yep, it's rounding. Now, see, in real world, you would have went, since that's 30 or more, you would have went over. You would have just clicked up to 36. So that's the difference between academia and the real world. Which that's not that big of a deal, but you know, on a test, I'd probably take both answers. Capiche? That's a good test question. Okay, I don't know if I'm gonna finish or not. Let's see. Yeah, I've got a few minutes. I've already taken the roll, so some of y'all can convulse out of the room whenever. Okay, 9.183. This might be the same question. Yeah. The reason this is a difficult question, I'll tell you why, is because it's not written like this. Change this into degrees. Well, you do that real easy. You put a 1 there and you put 180 over pi. And you cancel the pi's and you get 3 times 180, which is 5 something. I don't know, 3 times 180. And that's degrees. And you would do that without no problem. But the problem is when they give you one like this and it doesn't have a pi there, this means that pi is calculated into 4. Okay, that's what that means. So just for instance, I'd take 4. Let's take 4 and divide by pi. So technically I've got, this is 1.27 ... pi. Now I can change this, put this over 1, multiply this by 180 over pi, or I can just multiply this by 180 over pi, and I'll get the same answer. Here I can see the pi's canceling. Here I can't because pi is calculated in there. That's what's causing you to be a little bit, you know, apprehensive about these questions. So 1, that means that 1 has a pi in it. So 1 over 1 multiplied by 180 over pi gives us 180 over pi, which if you divided that, you would get 180 divided by pi, and that would give you 57.2957791 degrees. And then you would change that. So I'm on minus 57 and multiply that by 60. And that's 17, 57 degrees, 17 minutes, minus 17 multiplied by 60. And that gives me 45 seconds. So that's going to be 57 degrees, 18 minutes. So your answer is 57:18. This one should be the next size up. 5718, it should be. Yep. Those are two good test questions. And the last one is 9.183/21. I can't believe we're going to get all our homework questions in today. And I covered length and all that. Same thing, 6. So I'm going to throw this pen away. This pen's dead. So 6 has pi calculated in it. So 6 over 1 multiplied by 180 over pi is equal to 6 times 180 over pi. So 6 times 180 divided by pi. Third, 343 degrees, 0.7746771. I'm going to minus the 343, multiply by 60, and get 46 minutes. 343 degrees, 46 minutes, minus the 40, well, technically, yeah, minus the 46. And multiply that by 60. And that's going to be 29 seconds. So let's see what they want to round to. Round to the nearest minute. So that's going to be 343.46. 343 and 46. Okay. And I can safely say that we're finished with 9.1. So that means the last time I'll take questions on 9.1 is Tuesday. If I don't get any questions, then we're moving on to 9.2. Comprende?
Yes, sir.
Okay, so everybody's got a long weekend to work on 9.1 homework and review homework. So y'all should have that done and questions sent in. And that is it for the recording.